we want to find the distance between 2 points in the plane, and this is an application of the Pythagorean theorem. If I draw a line here and a line here, that is a right triangle. And this is the hypotenuse. The distance is the hypotenuse of a right triangle, where one leg is the change in x, and the other leg is the change in y. Now, these little cross marks here are not x's. Those are just there to mark the points. So I'm given that I have a point 4, 7, which is this one right here, and a point that is negative 4, 2, which is right here. So my actual formula here is that the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, the order of the points doesn't matter because the distance from here to here is the same as the distance from here to here, right? So when I square them, it doesn't matter whether this is negative or positive. It's going to become positive when I square it. So I prefer to think of this as delta is equal, or the distance is equal to, delta x squared plus delta y squared. Delta is the mathematical, or capital delta is the mathematical symbol for change. So to get from here to here in x, I have to travel 8, right? From 4 to negative 4. So this is 8 squared. And to get from here to here, I travel 5. To get from 7 to 2, so this is 5 squared. And that's equal to the hypotenuse squared. Take the square root of both sides. This becomes h, and I don't have to worry about the negative because distance can't be negative. So h is equal to, well, let's get away from the hypotenuse and back to distance. The distance is equal to the square root of 64 plus 25, and that is equal to the square root of 89. Make my radical a little more appropriate. And the square root of 89 does not simplify, so that is our final answer. I'll do another example for you. Distance is equal to the square root of delta x squared plus delta y squared. And the change in x is 5. The change in y from negative 5 to 1 is 6. And for many of us, we make fewer sign errors if we do it this way. So if you'd prefer, you can do it the other way. The most common error I see, though, is when students forget to take the square root after they've found the sum. So this is equal to the square root of 25 plus 36, and that is the square root of 61, and again, that does not simplify any further. Using the formula, we have distance is equal to the square root of 5 minus 0 squared plus negative 5 minus 1 squared. And so this is 6 squared, and this is, this is 5 squared, getting ahead of myself, and this is negative 6 squared. And you can see where the opportunity for sign errors is, both in the actual subtraction here and then also in squaring the negative 6. This is still the square root of 25 plus 36, which is still the square root of 61. Whichever method works best for you is fine.